All right, our next topic here deals with elastic and inelastic collisions. We're going to take a look at the elastic collisions mainly because there's a derivation of a couple of formulas that's really important. But the inelastic obviously is the opposite of elastic, but let's deal with the elastic collisions first. When that happens, the law of conservation of momentum and the law of conservation of energy are both satisfied. They're both fulfilled. Inelastic collisions, the law of conservation of energy is definitely not conserved. The law of conservation of momentum may or may not. Usually it does, but sometimes it doesn't. But this is a must, that this is not conserved. So we're going to be taking a look at that later. We're going to start off with the law of conservation of momentum. Now, the law of conservation of momentum states that whatever momentum you have before between two objects is going to be what you have afterwards. So we use m1 for the first mass, first velocity, second mass, second velocity, and then we introduce this prime here. And the prime is basically saying the velocity, the mass is going to stay the same because we don't have that symbol up there, but the velocities of the two objects will most likely change. Law of conservation of energy is 1/2 mv squared is what kinetic energy is, so we're looking at it in terms of the kinetic energy, and it's the same idea as what we had up there, only now we got a half, and we're squaring the velocity. Both must be true if you have an elastic collision. Now what the heck is an elastic collision? An elastic collision is when two objects collide, and as the definition said, both of them have to be confirmed, but basically it's like in the air, the molecules in the air, when they collide, they don't slow down. They keep moving at the same momentum they had before between the two of them. Okay? If that didn't happen, then all the molecules in the atmosphere fall down the ground. We have to breathe with our necks straight to the ground. Thank goodness that's not the case. So, since we have these two equations, and immediately to make things easier for us, I got rid of all the halves. Divide everything by half, or multiply everything by 2, and that eliminates those creepy fractions. What I'm going to do now is I'm going to do what the book did, only the book did an absolutely horrible job of explaining itself. And I want to make you understand, now you don't have to know how to do this, but I'm going to tell you something. When you get into upper level education, you're going to be asked to do things somewhat similar to this. And everything that I do here follows basic laws of algebra, with some creative thinking outside of the box, but it still has to follow the rules of algebra. So follow along on the logic for this. There's a lot of therefores in this. All right, so in this scenario, we know what the two masses are. We know the two velocities are to begin with. We know the two masses after the collision because that doesn't change. What we don't know is the first and second object's velocities after the collision. So we got to figure out how to find both of those things from this mishmash of equations. So what we're going to do is I'm going to take the law of conservation of momentum, and I'm going to move everything to one side of the equation. So subtract this and subtract this to get this. And when I do that, I'm going to combine the m1 v1 and m1 v1 prime here, take out m1, and that leaves me the fraction v1 minus v1 prime, and I did the same thing with m2. And when I did that, then I put them back away from each other. m1 times v1 minus v1 prime equals negative m2, because I moved this whole thing over to the other side of the equation, times v2 minus v2 prime. I'm calling that equation A. It's a point of reference I'll come back to. Likewise, I'm going to do the same thing with the law of conservation of energy. This is what I start with. I do what I did up there. I move all that second side over here by subtracting them, and that gives me 0. and then I factor like I did up there, and that still equals 0. And then I factored out the M1 for 2 of them, the M2 for 2 of them, and then I moved the M2 back over and I subtract. Exactly the same process for those two equations. Now the fun begins. And if I'm going too fast, stop it and kind of look at it. Maybe take notes. Okay? We're going to come up with a new equation. Oh, yeah, that's equation B, by the way. I've called that equation B. That is equation B. Now what we're going to do is we're going to form a new equation, which is the result of taking equation B and dividing by equation A. Now I put up there, before the color marks there, I put up there what equation B was and what equation A was, and I divided them out. And when you divide, we have, now the equal sign is separating these two sides, so I can do things on this side, the equal sign, and I can do things on both sides of the fraction on this side. The M1s will cancel out here, the M2s will cancel out here, and the negative signs I have will cancel out here. That's why I have 3 different colored slashes. So you can see what happens. That leaves me this. Now, if you remember from algebra, these are differences of squares, and you can factor out differences of squares by taking V2 minus VI, V2 minus V1 minus V1 prime times V1 plus V1 prime. Same thing over here. And that's going to allow me to have a cancellation take place on both sides of the equal signs to leave me V1 plus V1 prime equals V2 plus V2 prime, which can become V1 minus V2 equals V2 prime minus V1 prime, which will give me this. I can use any of these, again, for whatever purpose I may need. Just saying. Okay? Now, I've created this equation C, that final equation down there. And I'm going to combine C and A together to get rid of V2 prime. That's the whole point. I should have V2 prime up there. So I'm going to get rid of V2 prime. So I'm going to set V2 prime as equation C, so that's equal to V1 plus V1 prime minus V2. Just by moving or adding this V1 to this side over here, I have to switch sides at that point. And that's where I got that from. Now going back to equation A, and what I'm going to do here is I'm going to divide both sides by negative M2. And I'm going to move this over here and this over here. So that means that if I divide by negative M over 2, then I'm going to have that moved over here as a fraction, and this stays intact. And then I'm going to have V2 minus V2 prime left on this side over here. Remember, I just switched sides. It's nothing magical. But I did divide both sides by negative M2. And that's key. Why? Well, when we do this, I now can get V2 by itself, V2 prime by itself, which is what I want to do. I'm trying to get rid of the V2, so I have an equation for V1 prime. When you have two unknown variables, you may have to go to simultaneous equations. That gets really ugly when you start getting squares. What we're going to end up here with a much better form of the equation. Okay. So now, I have this equation here, but I need to get rid of that negative sign. So I'm going to multiply everything by -1 over here, make this positive, and this is my equation. And what is important about this is that in equation C, I end up with this for V2 prime. Equation A, we end up with this for V2 prime. Now I can do a little substitution. I'm going to take this expression from equation C and stick it in right there, and that gets rid of my V2 prime, and the only unknown I have now is V1 prime, so I need to isolate that V1 prime so I can set it equal to in our calculation. So this is what I have. Okay? Now, the next thing I'm going to do is I'm going to get V1 prime by itself, so I'm going to move this over here by subtracting, and I'm going to move this over here by adding to this. That gives me two V2s. Next thing I'm going to do is I'm going to multiply out this M1 over M2, or distribute it across these two parts of the parentheses, and I get this. Everything else stays the same. Nothing new here. This is all stuff you've had in algebra. And the reason why I'm doing that is because I want to get V1 prime isolated. So I get V1I by itself. But I have to get all terms that have VI in it together. So I move this over here. I'm sorry, I already did that. I'm going to, I move this over here by adding. Everything else stayed on that side. And then I'm going to factor out a V1 prime out of both of these terms. That leaves me 1 here. And I get rid of that. That leaves me M1 over M2 right there. So V1 prime times this quantity equals that stuff I have on the right-hand side. Well, this is perfect. Okay? Now, but before I do anything with this, I'm going to have to address the issue of this V1 here. I have two separate V1s. I'm going to combine that into one term. So I'm just using the commutative property by moving these two around and get them here. And then I'm going to factor out a V1 out of these two terms to make it now basically one term. I have the lowest common denominator here that I'm going to make. So that becomes M1 minus M2 over M2 in the denominator. Okay, and I did the same thing up here. I forgot to mention that. I have 1 plus M1 over M2. Lowest common denominator is M2. That becomes M2 over M2, M1 over M2, which is in this fraction. And that's what I have here. Did the same thing here. Okay, now I'm going to get the V1 prime by itself by multiplying both sides by this reciprocal. So I put this reciprocal here and this reciprocal here. The M2's cancel out here. And what I have left over then is this goes over this as a fraction times V1, these are gone now, plus I put the 2 over here by the M2, and I put the V2 outside over here. Commutative property multiplication, I can move things around as long as they're all multiplying, which they are. And I come up with this formula right here for V1 prime. I know, it's laborious, it's crazy, but there's nothing new. It's stuff that you know how to do. You just, when you get asked to derive stuff in the upper levels, which you will be asked to do, this gives you an idea of what they're looking for. Now, I'm not going to have you do any problems involving this, but it might be a good idea at some point to start looking at possibly being able to do that yourself. Try the quadratic formula. Quadratic formula that you use is the derivation of ax squared plus bx plus c equals 0, and doing the algebraic manipulations to come up with the quadratic formula. Anyway,